Hello students, let us continue with chapter 4, linear equations in two variables. Until the last class we were seeing how to plot your solutions to linear equations in two variables onto graphs. So continuing with the solved example, we are on the last one before starting a fresh new exercise. So this one is on page 73, example number 8. Let's read out our question. For each of the graphs given in figure 4.5, so here is my figure 4.5 and here are the three graphs that the question is talking about. Select the equation whose graph it is from the choices given below. So we have different choices out here. So for figure 4.5, 1, this is 1, figure 4.5, 2 and figure 4.5, 3. They have given us three equations, 4 equations for each, and we need to find out which out of these 4 equations is going to satisfy the equation of this line as well as this line individually. That means which one out of these 4 for figure 4.51 is applicable for this equation. Similarly, which out of these 4 is applicable for or satisfies this line's equation, and similarly for figure 4.53, which out of these 4 equations is going to satisfy the equation of this line. So let us start with the first one. So I'll write down the coordinates of figure 4.51, which are 1, 2, 0, 0 and -1, -2. So what exactly we're going to do is we'll take these equations one by one, substitute the values of these coordinates one by one and see if the coordinates, all 3 coordinates satisfy the equation. So whichever equation satisfies, that means whichever equation will hold true, that is the left hand side and right hand side would be equal for all these 3 coordinates, that would be the equation of the line for figure 4.51. So let's check. We'll do it for the first one, which is x plus y is equal to 0. Now obviously you have x is 1, for example the first one, you have x is 1 and y is 2. Adding them up, would it give you 0? No, it would give you 3. Similarly here, 0 plus 0 will give you 0, but how about the third one? -1 plus -2 is -1 -2, which is -3. So we can see that this equation is not standing true for all the 3 coordinates. So I'll quickly move on to the second one. Y is equal to 2x. Now I'm going to substitute. Obviously it becomes difficult to check, individually you might get confused. So let's just check for LHS and RHS using coordinates 1 and 2. So for x is equal to 1 and y is equal to 2, what do I have? LHS and RHS. My LHS is y, which is 2, and my RHS is 2x, which is 2 into 1, which is 2. So you can see that the LHS and RHS are equal. Therefore, this coordinate is working for this equation, y is equal to 2x. Let's check for the other two coordinates. For x is equal to 0 and y is equal to 0. I'll take my LHS and RHS. Again my LHS is y, which is equal to 0, and RHS is 2x, which is 2 into 0, which is equal to 0. So you see that LHS is equal to the RHS. Let's check for the third coordinate. For x is equal to -1 and y is equal to -2, what do I get? LHS and RHS. So this is y, which is -2, and this is 2x, which is 2 into -1, which is equal to -2. Therefore, you see that LHS is equal to RHS. So all these 3 coordinates satisfy the equation of my line y is equal to 2x. So I'm just ticking y is equal to 2x because it's holding true for all the 3 coordinates. But that doesn't mean that we halt over here. We will check for the other 2 coordinates as other 2 equations as well. So my third equation is y is equal to x. Now let us look at a coordinate. This is x and this is y. Is it equal? So x is not equal to y or y is not equal to x. Here y is equal to x, here also y is not equal to x. So the equation is holding true only for one coordinate, but we have to check for all the coordinates, right? So all the coordinates do not lie on the equation of this line. Therefore, this is also not the equation of your line of figure 4.51. So we'll check for the fourth one. The equation of my fourth line is y is equal to 2x plus 1. Let's check for one coordinate at a time. So I'll take for x is equal to 1 and y is equal to 2. My LHS is y, which is equal to 2. And what is my RHS? My RHS is 2x plus 1, which is 2 into 1 plus 1, which is equal to 3. So here again the LHS is not equal to the RHS. Therefore, even this equation is not the equation of my 4.51. Therefore, I am just highlighting this one over here. So y is equal to 2x represents the equation of line of figure 4.51. Let's move on to the B section of this solved example, which is for figure 4.52. So again I am going to write down my coordinates. My coordinates are first of all B. My coordinates are 1, 6, 0, 4. See, these are my coordinates. If you must be wondering where am I getting these numbers from, it is right here, 0, 4 and minus 2, 0. Right. So what I am going to do is again take these equations one by one simultaneously with these coordinates and see whether which equation, which line would have all these coordinates on it. So how are we going to check that? We are going to substitute the values of x and y of these coordinates one at a time. So for x is equal to 1 and y is equal to 6, or rather my equation is x plus y is equal to 0. Now over here, if you check for x and y, x is 1 and 6 is and y is 6. So does adding 6 plus 1 or 1 plus 6 give you 0? No. So this one is cancelled. This one is ruled out. Let's check for y is equal to 2x. So this was my first one. Let's check for y is equal to 2x. Now y is equal to 2x, that means whatever is the value of y, whatever is my value of x, twice the value of x should be that should that be of my y. That means if y is 2, then if x is 1, then y should be equal to 2. If x is equal to 2, then y should be equal to 4. So let's check over here. Here y is not equal to twice that of x. See, for 1, 6, 0, 4 and minus 2 and 0. Only for minus 2 and 0 you can say that it is twice the value of my, no, it is not really twice the value of my x over here also. So this one is ruled out as well. Let's check for the third one. So my third one is y is equal to 2x plus 4. Right. So now this one looks tricky, so we are going to go ahead and solve this. I will say for x is equal to 1 and y is equal to 6. What is my LHS? LHS is y, which is equal to 6, and let's check my RHS. RHS is 2 into 1 plus 4, which is 2 plus 4, which is 6. So you notice that the left hand side is equal to the right hand side. Let's check for the second coordinate. For x is equal to 0 and y is equal to 4. My left hand side again is y, which is equal to 4, and my right hand side is 2 into 0 plus 4, which is 0 plus 4, which is equal to 4. So my left hand side is equal to the right hand side. So let's check for the last one. For x is equal to minus 2 and y is equal to 0. So what do I have? This is left hand side is y, which is equal to 0, and right hand side is 2 into minus 2 plus 4, which is minus 4 plus 4, which is 0. So therefore the left hand side is equal to right hand side. Therefore this equation 2x plus 4 is satisfying the equation of my line of figure 4.52. Let's check for the last one also. Y is equal to x minus 4. That means we let's check over here only. Y is equal, suppose y is 6 and x is 1 over here. So is y 6 is equal to, or rather just check it. I have y is equal to the fourth one, x minus 4. So for x is equal to 1 and y is equal to 4. X is equal to, y is equal to x minus 4. So x is equal to 1 and y is equal to 6 for the first coordinate. So this is LHS, which is y, which is 6, and my right hand side is x minus 4, which is what? 1 minus 4, which is equal to minus 3. So therefore the left hand side is not equal to my right hand side. Therefore this equation is also ruled out because all the coordinates given are not lying in the equation of my line. So which one is true for figure 4.52? It is this one, right? Let us go ahead and solve for the third one. So my third one, I am going to write down my coordinates like I did in the previous two ones. So my coordinates are 2, 0, minus 1, minus 2, 0, minus 4, and minus 1, minus 6. So let's check for the first one, x plus y. Is x plus y adding x plus y giving me 0? No, it's not giving me a 0 here, it's not giving me a 0 here, neither here nor here. So x plus y is ruled out. This equation does not hold true for all these coordinates. That means these coordinates do not satisfy the equation of line x plus y is equal to 0. Let's check for the second one. Y is equal to 2x. So is y twice the value of x? Is 0 twice the value of 2? No. Is minus 2 twice the value of 1? No. Is minus 4 twice the value of 0? No. Is 6 twice the value of minus 1? No. So even this is ruled out. Let's check for the third one. Y is equal to 2x plus 1. So this one looks tricky, so we'll just go ahead and solve it. I'll take for this coordinate for now. For x is equal to 2 and y is equal to 0. What is my left hand side? Y, which is equal to 0, and my right hand side is 2x plus 1, which is 2 into 2 plus 1, which is 5. Therefore left hand side is not equal to right hand side. Therefore this equation is also ruled out. That means these coordinates, there exists at least one coordinate, for example in this case this one, which does not satisfy the equation of the line y is equal to 2x plus 1. So obviously now since all the three did not work, the fourth one is definitely the one that satisfies the equation of the line of figure 4.53, but we will go ahead and verify. So the fourth one, you have y is equal to 2x minus 4. So I am going to check individually for each coordinate. For x is equal to 2 and y is equal to 0, my left hand side and right hand side. This is y, which is equal to 0, and right hand side is 2x, it's 2x minus 4. So 2 into 2 minus 4, or 2x minus 4, let's just go in order. 2x minus 4, so this is 2 into 2 minus 4, which is 4 minus 4, which is equal to 0. Therefore, the left hand side is equal to right hand side. Therefore, this one is working for my equation y is equal to 2x minus 4. Let's check for the other coordinates as well. For x is equal to 1 and y is equal to minus 2. My left hand side is y, which is equal to minus 2, and my right hand side is, so my right hand side is 2x minus 4, which is 2 into 1 minus 4, which is 2 minus 4. So 2 minus 4 is minus 2. Therefore, the left hand side is equal to right hand side. Now, let's check for the third coordinate. This coordinate is lying on my equation y is equal to 2x minus 4. So, I will check for my third coordinate. For x is equal to 0 and y is equal to minus 4. My left hand side is y, which is minus 4, and right hand side is 2x minus 4. So, this is 2 into 0 minus 4, which is 0 minus 4, it is going to be minus 4. Therefore, left hand side is equal to right hand side. Therefore, this coordinate also lies on the equation of my line y is equal to 2x minus 4. Finally, we will check for minus 1 and 6. So, for x is equal to minus 1 and this is minus 6, and y is equal to minus 6. What do I get? Left hand side is y, which is equal to minus 6. So, my right hand side is 2x minus 4, which is 2 into minus 1 minus 4, which is minus 2 minus 4, which is minus 6. So, again left hand side is equal to right hand side. Therefore, which equation holds true for figure 4.53? It is the fourth one. Please take a look. So, with this we have completed the solved examples before starting the fresh exercise, which we will see in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.